AI leaderboards seem simple. They rank models with scores, telling us which one is best. But treating those scores like a report card is a surprisingly common mistake, and it's a costly one.
This isn't just a theoretical problem. It leads to flawed decisions, with real-world consequences for businesses and developers who rely on a number that doesn't actually tell the whole story. So to really get to the bottom of this, we have to look at what these benchmarks are actually trying to do. You can think of them essentially as an AI's report card.
At its core, an AI benchmark is just a standardized test. The whole idea is to create a common reference point, a level playing field to measure and compare different AI models. It's supposed to be just like a standardized test for students. And how it works seems pretty straightforward, right? First, there's a test dataset. That's just a set of problems for the model to complete. Then you have an evaluation method, which is basically the rules for scoring the model's answers. And finally, all of that feeds into a leaderboard that ranks how the model's performed. On the surface, it looks simple, objective, and fair. But that simple, objective grading system has a critical flaw, and it's a flaw that can make the results not just a little off, but completely misleading. The problem is something called data contamination. It's almost like the model is studying for the test, but not in a way that actually involves learning. Really, the best way to picture it is this. It's like grading a student on a test when they've already seen all the answers. So what's actually happening here? Data contamination occurs when the test questions from a benchmark leak into the massive datasets used to train an AI. This means when the model is eventually tested, it isn't actually reasoning. It's not problem solving. It's just remembering. It's recalling the answers it was already shown. And this is where you see the huge difference between genuine capability and simple memorization. A truly capable model can generalize. It can tackle new problems. But a contaminated model just looks capable. Its scores are inflated, which creates this false sense of confidence. But the moment it faces a real-world task it hasn't seen before, it fails.
What's fascinating is that this problem, this whole idea of teaching to the test, it's not new and it's definitely not unique to AI. It actually points to a much deeper, long-standing challenge in science itself.
This brings us to a familiar problem in the scientific community, something known as the replication crisis. So the replication crisis is this widespread issue where scientists find they can't reproduce the results from many previously published studies. And this is a huge deal because reproducibility is supposed to be the bedrock of the scientific method. When it fails, the credibility of those original findings gets called into question. And if you look at the causes of the replication crisis, they start to sound, well, pretty familiar. You've got publication bias, this tendency to only publish positive results. You have the intense publish or perish pressure on researchers. And then there are questionable practices like p-hacking, where data is manipulated just enough to find a result that looks significant. And here's the connection. The intense competitive race for the top spot on AI leaderboards creates the exact same kinds of pressures. It creates an incentive to chase high scores above everything else, and that can lead to results that look amazing on a leaderboard, but just aren't reliable or reproducible in the real world. But that brings up an even bigger question. Let's just say for a moment that a benchmark is perfectly clean, no contamination at all. Does getting a high score on that test guarantee the model will actually be useful in the real world? And this gets to the final and maybe most important challenge, the huge gap between what these benchmarks measure and what the real world actually demands from an AI. Just look at the difference. On one hand, you have standard benchmarks. They focus on very narrow tasks, using clean, unambiguous data. A lot of the time, they're just testing for factual recall. But then, there's the real world. Real-world problems are messy. They require very specific domain knowledge, they have to deal with ambiguous inputs from users, and they often involve complex, multi-step conversations. Okay, so if public benchmarks can be contaminated, and even when they're not, they don't really reflect reality, what's the alternative? Well, it turns out the most accurate evaluation comes from creating tests designed for a very specific purpose. This is why custom evaluations are so powerful. First, by using private data that the model has never seen, you completely eliminate the contamination problem. But more importantly, you can design tests that perfectly match your real-world needs, tests that are tailored to your industry's jargon and nuance. And when you do that, you get metrics that truly predict how well that model is going to perform when it's actually doing the job.
So, the real takeaway here is that we need to change how we think about these scores. A number on a public leaderboard isn't the finish line, it's not the final word. It's just the starting point for a much deeper, more meaningful evaluation.
And all of this leaves us with one last, big question. If the public leaderboards that everyone watches are this flawed, how should we, as an industry, as a society, really be measuring true progress in AI?